Okay, now let's solve the problem 20, moving averages and exponential smoothing method. Here are three different forecasting methods are given: 3 months moving average, 3 months weighted moving average, and exponential smoothing method with alpha 0.3. Then using MAD, mean absolute deviation, you need to determine which method is the best forecasting method. Since MAD, mean absolute deviation, indicates the forecasting error, the smaller MAD, the better method. So we have to determine best forecasting method with least MAD. Okay, now actual demands are given. Using that, we have to forecast the value. Starting with the 3 months moving average. So starting with the month 4, we are taking the average value of past 3 months to forecast the month 4 and copy the formula. They are asking to calculate the simple 3 months moving average for period 4 through 12. So now is absolute deviation. So we are taking the absolute value between actual demands minus forecast value. And then copy the formula here. And there is no absolute deviation between the months 1 through 3, months 1 and 3, because there is no forecasting value. Then we are simply taking the average value of absolute deviation. That become your mean absolute deviation for 3 months moving average. Okay, next one is the calculate the weighted 3 months moving average using the weights of 0.5, 0.3, and 0.2. As you recall, the weighted moving average, the weight scale are given. So you are given different weight to different data value. The highest weight is given to the most recent data, and the lowest weight is given to the oldest data. So starting with here, 0.5 times most recent data, which is month 3, plus 0.3 times month 2, and plus 0.2 times the oldest data, which is month 1. Then you can copy the formula. Then taking the absolute value of the deviation between actual demands and forecast value. Then you are copying the formula. Then you can take the average value of or the absolute deviation. Compare these two methods. The 3 months weighted moving average generate the smaller MAD, which is better method because that contains the smaller forecasting error. Let's do the exponential smoothing with alpha 0.3. You have to note that for exponential smoothing method, the initial value should be given. Because f1 equals f0, but f0 is not given here. We don't know. So we have to know the initial forecast, which is f1, which is 61. So you put the 61 here. From the second month, using this formula for exponential smoothing, ft equals ft minus 1 plus alpha times at minus 1 minus ft minus 1. So f2 equals what? f1 plus alpha is 0.3 times a1 minus f1. So here f1 is previous forecasting value times 0.3 times previous actual demands minus previous forecasting value. Right? Then click, then copy formula from here. Then asking the calculating the mean absolute deviation for forecast made by each technique in period 4 through 12, starting with period 4. An absolute value of actual demands minus forecasting value. So we are taking the only absolute deviation from period 4 through 12 to compare, to be fair with this to other forecasting method. Then taking the average value of the absolute deviation. Oh, the MAD become very high. So here, the answer is the 3 months weighted moving average appears the best. Why? So 3 months weighted moving average seems to be the best because of lowest MAD. That is the smallest forecast error. That's the answer. Okay, thank you.